Hi everyone, this is the gas walkthrough for May 8th. I'm Philip Newman, and I am solving Cupid Sudoku ILYSM by Bill Murphy. I assume the ILYSM stands for I love your sauropod memes. I can't think of anything else that might stand for. Anyway, this is a Cupid Sudoku, obviously. We've done some of these before, but we'll review the rules. And we have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some gray arrows in the grid. And a gray arrow means whatever digit is on the gray arrow must also appear somewhere else along the diagonal that the arrow is pointing to. And those are the rules. The example it gives is R3C7. So this arrow must contain a 9 or an 8 because those are the only digits that appear on that diagonal. So let's start like we did last time we solved one of these. I think we did one fairly recently, actually. We want to start with the shortest diagonals. So the arrows that are pointing closest to the edge of the grid. So this arrow is pointing at one cell. So this arrow means whatever digit is in this cell, which is a 2, must appear on this diagonal. So that's a 2. We have a 4 here, we have a 6 here, and we have an 8 here. The next place to look is this 1. This is a 3-cell diagonal. However, we've already filled 2s in 2 of those cells. So the only place left for this 1 is here. The 3 can only go here, 5 can only go here, and the 7 can only go here. Okay. Now we're going to look at these arrows, one of which was the example. We're going to start here. We need some digit here to appear in these 2 cells. So it has to be a 4 or a 9. However, there's a 4 in the row, so this must be a 9. Now, since this is a 9, this can't be a 9. And we said that had to be a 9 or an 8, so this is an 8. Now, this also has to be a 9 or an 8, and since this is an 8, this is a 9. And this has to be a 9 or a 4. Since this is a 9, this is a 4. Now we have 2 more arrows, and they are pointing at arrows we've already looked at. So this arrow is pointing at these 3 cells. Well, the only digits here are still 8 and 9. We had 8 and 9 in these 2 cells already, and then this arrow was pointing at these. So this needs to be an 8 or a 9. We have a 9 in the box, so that's an 8. And this needs to be a 4 or a 9, and we have a 9 in the box, so that's a 4. And that is all of the constraints, so we're just doing classic Sudoku at this point. So I see I have 2 1s here. Where do they go in box 7? Only there. The 2's here. 2 must go there. 4 here must go here. And actually I had 4's all over that. 4 here, because of these 4's, and this 4 for that matter. Where does 5 go in this box? There's a 5 here, so it can't go in those cells, so that's a 5. The remaining digits here are 1, 2, and 3. So the remaining digits in the row are 6 and 7, and we can resolve that. Okay. 5 here. 3 goes here. Okay, in this box, I can see, well, I can do this 2 ways. I can see these 2 cells can't be 6 or 8. So the 6 and 8 in the box must go here. Also, there are 8s looking into this box. So this is the only place for 8, and this is 6. And then these are 7 and 9, and they're not 7 and 9, 7 and 5. There's a 5 here. So that's resolved. These are 1 and 9. We have a 9 down here. And these are 6 and 7, resolved by this 7. This is a 1. It's the last digit in the row. These are 5, 6, and 7. And we can clean that up a little bit. We can clean the 2, 1, 3 from up here. All right, these are 1, 2, and 7. And that leaves 3 and 6 in the box. That leaves 2 and 8 in the column. So that's 2 and 8 from that 8. These are 1 and 3, which are also resolved. These are 2 and 3, resolved by that 3. These are 5 and 9. Now these are 2 and 7. And these are 3, 5, and 6. Okay, I don't see anything else in the outside boxes. Maybe I'm missing something, but we can look into the central box, and we have all of our 9s except for 1. This is the only place for 9. And in fact, we could have placed that 9 from the very beginning because of these givens. We have a lot of 4s looking in, so our last 4 must go here in the central box. About 8. Yeah, 8 is also resolved here. Alright, I don't know that this is totally necessary, but it's what I saw next, so I'm going to use it. What are we missing in the column? We're missing 1, 3, 5, and 6. This cell, however, can't be a 5, and we also have a 3, 6 pair in the row, so this has to be 1. This is 3, 2, 1. And now this is 5 or 6. This is not 1, so the only place for 1 in this column is here. Now I assume we can do the same sort of thing here with the 2, 7 pair. So in this column we need 5, 2, and 7, and the 2, 7 pair here. It's a little more straightforward because we placed that 1 there, I guess. So 7, 6, 5 here, that's a 6. And now that's going to resolve our 3, 6 pairs. This is now a 5 and a 6. And in the central column, we need 3 and 7. And do that. This becomes 2, 7, 2, 7, and 2. And that is the solution. Yeah. The variant there was pretty straightforward. The classic was maybe a little trickier. But I hope you found that okay, and let us know how you did in the comments, and I will see you next time.